Dear students, in this video, you will get knowledge about the differences between PET and CPM. Okay? So, what is PET and what is CPM? That I will explain now. Share my screen. So, this is the difference between PET and CPM. So, this is especially as a single entity we are calling with the name project manager. Okay. So the PET and CPM, these two are the different techniques for the different perspectives. So here I have given some listing of the differences between PET and CPM. So first of all, what is what, right? So that means program evaluation and review technique. Right? So it is generally called PERT, right? And here it is critical path method. So both of these having a combined characteristics of drawing a network. Here I am drawing a very simple network. So I am taking just 4 activities only, right? So this is one event, second event, third event, and fourth event. Event means a point of time. Okay. So here I am taking activities between 1 and 2 event will be A, 2, 3 will be B, and 1, 3 will be C, and 3, 4 will be D. And the time period I am taking here A 7 days, B 3 days, and C 8 days, and D 4 days. Okay. Now I am calculating the earliest expected time for the events 1, 2, 3, and 4. It is possible. Yeah. So the first one, obviously, it is starting with the 0, right? And for each and every event, in the earlier videos also, I explained how to calculate the TE and TL, right? So for the event 2, only one proceeding it is having, so 0 plus 7, it will be 7. And for 3, we are having the 2 proceedings, 0 plus 8, 8, 7 plus 3, 10. So maximum I'm taking 10. And the last event 4, 10 plus 4, 14. And the TL value will also 14. Because the last event, the earliest expected time itself will become the target. So coming back, for 3, 14 minus 4 from the succeeding, it is 10. So for 2, it will be 7, and for 1, it will be 0. Now, again, I am changing my color. Okay. Green. So now I will, this is for your explanation only to understand. So event where T is equal to TL, it is called critical event. So 1 is critical, 2 is critical, 3 is critical. Event, it is only the critical event but not critical activity. Okay. So how to find the critical activity? So it is finding 1 is a critical event and 2 is a critical event. So joining 1 and 2, there is an activity A with 7 days. So whether it is critical or not, 0 plus 7 is equal to 7. So A is also deemed to be critical. It is critical activity. Now what is for the B? 7 plus 3 is equal to 10. So it is critical. So A is critical, B is critical. A is a critical activity, B is a critical activity. What about the C? 0 plus 8 not equal to 10. So C is non-critical activity. And 3, 4. 10 plus 4 is equal to 14. So D is a critical activity. Now you remember, these calculations are based on the activity times 7 days, 8 days, 3 days, and 4 days. This is especially valid for critical path method, right? So here we are having certainty, but in fact, we don't have such certainty, right? And you look here, regarding the critical path method, it is clearly said it is activity oriented. So what is the activity A? How much time it will consume? So based on this, we will calculate project duration. Okay, but what about this step? It is event oriented. Event means it is time. Event means it is time. Okay, at what time so we are able to complete some activities? So we are searching for time. Okay, not for the activity duration, nothing else. At what time your project is completed, right? What is the probability of completion? Like this, we'll ask in PERT. So what we will do here, planning and control of time. So within 28 days, how much it will be completed? Within 38 days, how much it will be completed? What to do? How to control the activities of reducing the time? So all this will be in PERT. And again, what we will do, managing uncertain activities. So uncertainty is an integral part of PERT. Okay. So why we are having the uncertainty? It is not because of some other external factors. These are internal only. So what is that uncertainty? I will explain in the next slide. And PERT is evolved as a R&D project. R&D means research and development. What is going to have the research and what we develop? So here the research means how to control the project activities and how to reduce the uncertainty and how to estimate our project completion time more or less accurate, right? And most important thing, it is probabilistic model. It is completely probabilistic, right? So what is that probability? I will explain. And in contrast to this, what about the critical path method? It is activity oriented. So activity means between two events, we are having a connectivity bridge, that is activity A, activity C, activity B, and activity D like this, right? And we are controlling cost and time. In PERT, we don't find anything related to the cost, but in CPM, we are controlling the cost and time. So at what time it will be completed and how much cost is consumed, right? So there is a cost to time trade-off. And managing well-defined activities. Here, well-defined means 100% certain, right? Well-defined means at what time it could start, at what time it could end. A very clearly defined. So there is a certainty. And evolved as construction project. Construction means there is a well-defined parameters for a construction project. So foundation, next making some finishing works, and next slab, next completion of walls. Like this, you are having very clearly defined steps of progress. Okay, and in contrast to the PERT, it is a deterministic model. Once you are having the certainty, certainty leads to deterministic. So what is the probabilistic? What is the deterministic? Now we can see in the next slide. See, PERT focus on time and CPM focus on time cost trade-off. And you remember one thing, there is one process in CPM, that is cost slope. Cost slope means generally this cost slope what is coming with respect to the concept project crashing. Here the crashing means there is an activity between I to J. So this is activity as a, the time for it is Tij under normal conditions, right? So Tij will be some 7 days, and the cost associated for this activity may be 2000 rupees. Let it be. Okay. Suppose I want to reduce the time period by doing something. What is the doing something? Extra resources. So normally we are having some resources and we are consuming 7 days and we are spending 2000 rupees, right? So this 7 days is normal time, 2000 is normal cost. By using these extra resources, you are able to change the cost and time parameters. Now the cost became 6000 and time becomes 3 days, right? So instead of 2000, the total cost will become 6000 and the time will be reduced from 7 days to 3 days, right? Now these two are called crash parameters. This is called crash cost and this time is called crash time. What is the cost slope? Now from your data, normal time, crash time, normal cost, crash cost, right? So cost slope means how much money you are spending, question mark, how much money to reduce the duration by 1 day. Here, day is only a time parameter. It can be hour, it can be minute, or it can be week, something. Okay, it is a time unit. Now, from your given data, see, this is 2000, this is 6000. So the difference is actually the cost slope we are calculating with the formula delta C by delta T. Change in the cost, change in the time. So this is 4000 difference is there by the time difference 7 minus 3, 4 days. So this is 1000 rupees per day. That means to reduce the project by 1 day, you are spending 1000 rupees. This is called cost, right? This is possible only in critical path method, right? But in the PERT, you don't have the certainty. Once you have the certainty, you are able to crash it by using the some extra resource. But in PERT, you don't have certainty at all. Without having the certainty, how you can crash? So crashing is possible only in CPM. There is no question of crashing in PERT because once you are having the certainty, then only you are able to apply the crashing. And here you see 3 time estimates are there in PERT. Only 1 time estimate, that is activity time, that is certain time. Clear? Okay. So what is float, what is slack, I will explain. Here the 3 time estimates, these are actually so here for any activity we are having 3 times TO, generally somebody may call T0, right? TM, TP, right? For any activity, remember, right? Because we are having uncertainty of time duration, we will do some experimentation. So statisticians are saying very clearly, if anybody perform, anybody means not ordinary person, a well-trained, well-informed person like you and me. So if you do the activity some n number of times, let it be some 100 times, and record your time period of the activity. So I will get T1, T2 up to T100, right? Same activity, same activity. Okay. So 100 time periods I will get. So out of 100 time periods, there will be some times like 2.47 seconds. It might be repeated some 20 times, 1.56 times minutes. It can be repeated only 3 times, 3.16. It can be repeated 8 times. Like this, if you draw a graph between the time period and the x-axis and the frequency and the y-axis, you will get a curve like this, right? This is bell-shaped curve and it is following normal distribution, right? So this is according to the statistics. Based on the normal distribution, if you go for standard deviation, plus or minus 1 sigma, plus or minus 2 sigma, plus or minus 3 sigma. So I am taking plus or minus 3 sigma limits. In plus or minus 3 sigma limit, this time period is called TO, or this time is called TP, and this is called TM. So what is TO, TM, and TP? TO is optimistic time. Optimistic time estimate we are calling. So optimistic. Optimistic means everything is positive. Optimistic. All are optimistic. Suppose you are a employee, right? So everything on that day, it is completely positive to you. Be optimistic means, so today you are, including your personal things, all personal things, your societal things, and your organizational relations, everything is optimistic. So today your lunch, your morning tiffin is very nice, right? You got your bus exactly at the time, no hurry at all, and you got a very comfortable seating, right? Everything is optimistic, remember. And after entering into your organization, many people greeted you with a good morning, and your working conditions are so pleasant, right? And the materials and everything, they didn't find any problem. So your working is, everything is well, right? So under all optimistic conditions, if you are able to complete a work in a certain time, that certain time is called TO, optimistic, right? And again, we are trying to last. TO is completely optimistic. TP is completely pessimistic. Completely pessimistic means everything is wrong. Everything is wrong, right? Starting from morning onwards until your organization, your duty is completed, your concentration levels are not good, your energy levels are not good. So many people criticize you, right? While you are working in the organization or outside the organization, right? You are finding some difficulties, right? Completely difficulties. That in that situation also you are able to do your work content. So it will take a lot of time because your concentration levels are very low. It will be extended. So this is called pessimistic time or pessimistic time estimate. It is the maximum time. It is the minimum time. In between, now you can estimate one thing. For any person, any organizational people, or either you or me or somebody, 100% optimistic or 100% pessimistic is not possible many times, right? Out of 100 times, you may have 6 times or 7 times, there may be TO. 5 to 6 times, it may be TP, right? Completely bad days or completely good days will not be there, right? Most of the time, it will be a mixing, right? So today, you are unable to catch the bus, you are changing your college bus with your some other bike lift or auto or somebody, right? By the time you come to the college, everything is fine, right? So it is a mixing, right? Like this, most of the time you are having the mixing. If the time period is repeated any number of times, it is called most likely time. Got a point, right? So T0, TM, TO, TM, and TP, right? Now, if this is the situation for a single activity, what is the time estimate? How can I calculate the time estimate for an activity and subsequently for the total network? So there is a formula already I told earlier. T T suffix small e is equal to T0 plus 4 Tm plus Tp by 6. How to calculate this time? By using Excel, and how to calculate the range, variance, and the standard deviation. And after that, what is the probability estimate? I already explained in my earlier videos. Please go through it. And the last item, to have the differential between PERT and CPM. So in CPM, the term float is used. Float or slack. Floating means on the water, in the water, if something is floating, right? So it is giving a pleasurable feeling, right? So for any activity, the pleasurable feeling is you are able to delay the event, right? Here, the same situation in PET, we are using the word slack, right? Generally, the slack we are applying for, because the PET is different, slack for the event and the float we are applying for activity. Okay. So for activity, we are calculating the floats. That is, 3 floats will be there: total float, free float, and independent float. How to calculate this? Already I explained earlier. And event slack is the difference between the TE and TL. Already in just now we calculated. And see, for events 1, 2, 3, 4, we calculated TE and TL. But here, because the network itself is a very small network and it becomes completely all the events 1, 2, 3, 4, everybody became critical. We are unable to get the difference. If you are having any some other network, we could find the difference between TE and TL, right? That difference we are calling event slack. Okay. So this is the discussion about the PERT and CPM differences. Thank you very much, my dear students. I will stop the sharing. And for any video, we are having the last 3 dialogues. One is, if you like the video, subscribe and share it. Okay. Thank you very much.